Hi students, good morning you all. Hope all of you are doing fine. So today we are going to discuss another important topic in the chapter basic concept of chemistry. Okay, so here the topic is vapor density. Okay, so first I will try to define what is vapor density. Okay, so basically when we see the term vapor density, we will assume like it is the density of the vapor or of that particular gas, correct? So it is similar, but here this is also a relative quantity. So when we say molecular mass, we say molecular mass is always relative to 1 by 12 the mass of a carbon 12 atom, right? Similar to that, the vapor density is defined as, listen here, it is defined as the ratio of density of the gas to the density of hydrogen at same temperature and pressure. This is called vapor density. So right now we will say vapor density is equal to density of the gas. Vapor density of a particular gas. It can be anything actually. So for that, how we can say it is the density of that gas to the density of the hydrogen gas. Okay. Now, at same temperature and pressure, both gas and hydrogen should be at same temperature and pressure. Okay. That means if you take the density of the gas at particular temperature and pressure, you should take the density of the hydrogen at the same temperature and pressure. Usually the density of hydrogen is considered as 0.00089 gram per ml. Okay, that is 4 zeros are there. This you should remember basically. Okay, and how we can now derive the relation between the vapor density and molecular mass, that I will define. Listen here. Now I know that density, the standard definition is mass divided by volume. So I can say the density of the gas can be replaced as mass of the gas for 22.4 liter of that gas at STP. That means I am saying density of the gas as mass of the gas, okay, when it occupies a volume of 22.4 liters. Then many students will ask, sir, why you are taking 22.4 liter? Why can't we take some other volume? You can take, there is no issue. It is mass by volume only. But please remember, since it is a ratio, that is density of the gas to the density of hydrogen. If you are taking 22.4 liter in the numerator, then you should take the mass of hydrogen gas for 22.4 liter. That is the only thing you should remember. If you are taking here 1 liter, then denominator for hydrogen also you should take 1 liter, because it is a ratio. If you take it for any volume, at the end of the day, it becomes a fraction, simplest value. Okay. So that is the reason I have kept. And one more reason is there. When you take 22.4 liter, we know that any gas at STP, if it occupies 22.4 liter volume, it will have a mass is equal to molecular mass. This we have learned as the fundamental. That is the reason why I have chosen 22.4 liter. Okay. Now listen, I have now written here mass of the gas for volume will be 22.4 liter. That is what written. Mass of the gas for 22 liter of the gas at what temperature and pressure? At standard temperature and pressure. Now tell me how we write for hydrogen gas. Mass of the hydrogen gas for 22.4 liter of hydrogen gas at STP. That means hydrogen gas will have a mass when it occupies a volume of 22.4 liter at STP. Now tell me, what is this mass of the gas? We don't know. We can say always if any gas occupies 22.4 liter at STP, we can write that mass as molecular mass of the gas. Correct. This we have learned it. Please revisit our video mole concept in terms of molecules. There I have clearly mentioned if a gas occupies 22.4 liter at STP, it will have Avogadro number of molecules. Its mass will be equal to molecular mass. I have taught you this. Correct. So I can write this mass of the gas will be equal to molecular mass of the gas. Correct. Molecular mass of the gas divided by, now tell me again, hydrogen gas at 22.4 liter means that will be molecular mass of the hydrogen gas. We know molecular mass of the hydrogen gas, what is the value? 2, and molecular mass of the gas. So we are getting a fundamental relationship. Vapor density is equal to molecular mass of the gas divided by 2. That means vapor density of a particular gas is equal to molecular mass of the gas divided by 2. This is how we are deriving the relationship between vapor density and molecular mass. Okay. So I hope you understood the concept. Now we will try to do some questions based on this concept. So please take a snapshot if you need it. Okay, so there were feedbacks like, sir, we are not able to see the board at some point of time. So after the class, I will give some time for you to take a snapshot or something. Okay, for you to write down. You can pause the video and note down. Okay. So next we will do some questions based on vapor density. Okay. Okay students, so we have a question based on vapor density. I hope you could see the board very clearly. Okay, I will read the question, just go through it. Weight of 1 liter of gas is 2 gram. Calculate its vapor density and molecular mass. Okay, so this is the question. So we know from our fundamental definition, vapor density is equal to density of the gas divided by density of the hydrogen gas. Correct. So this we know. So here in this question they have mentioned weight of 1 liter of a gas is 2 gram. So we know volume and we know the mass. From that we can find out the density of the gas. So how you can calculate the density of the gas? So density of the gas is equal to mass of the gas divided by volume occupied by the gas. Correct? M by V, mass by volume. So mass of the gas, they have mentioned it as 2 gram. Okay. Now what is the volume? So I will usually express density as gram per ml. That is a normal way. So I know 1 liter is equal to how much? 1000 ml. So I can say volume is equal to 1000 ml and this is gram. So now tell me what is the density of the gas then? 2 divided by 1000. So this will be 0.002 gram per ml. Correct? 0.002 gram per ml, or you can write 2 into 10 power minus 3 gram per ml. So substitute that value here. You can substitute that 0.002 gram per ml divided by density of the hydrogen. We know this value. What is the density of hydrogen? 0.00089 gram per ml. Since it is a ratio, this will get cancels off. Okay, so if you are doing this, if you are dividing this, you will get a standard value, that is 22.4. Please remember, vapor density does not have any unit since it is a ratio. Okay, now they have also asked you to calculate the molecular mass also. So this is my vapor density. Okay, so molecular mass. Calculate its vapor density of the gas, that we have calculated, and they are asking you to calculate the molecular mass of the gas. So we know vapor density and molecular mass, how it is related. We know 2 times the vapor density is equal to molecular mass of the gas. We can write MW, molecular mass of the gas, is equal to 2 times the vapor density. Correct? So how you can write that? 2 into 22.4, that is equal to 44.8. 44.8. So what is the molecular mass of the gas? MW of the gas, we are getting it as 44.8. So we got 2 answers. So these 2 what they are asking you to calculate. So I hope you understood how to do this question. Okay, so we will switch to the next question. Hi students, so this is another important question that they usually ask for Neet or JEE. So even for school exams also, very important. So just go through the question. Calculate the number of atoms present in 1 liter of water. So they have given water, which is a molecule, and they are asking you to calculate the number of atoms. So surely here the concept of what will come into picture? Atomicity. But here one more problem is there. There is no mass for water is given. Only they have given the volume of the water. So many students will say, sir, this is 1 liter of water, right? So 1 liter of water they have mentioned. So why can't we calculate it for 22.4 liter and we can take the molecular mass? Don't go in that way. Why? Because they have not mentioned STP or anything. And we don't know whether water is in gaseous state or liquid state. If nothing is mentioned, if STP or nothing is mentioned, we assume by default water is in liquid state. Understood? Very, very, very important. So 1 liter of water. So we here assume water is in liquid state. So in that case, how we will proceed? So we know volume of the water. Volume of water is equal to how much? they have given that is 1 liter. Correct. So we know 1 liter is nothing but 1000 ml. Correct. Now we know the density of the water also, that is given in the question, and if it is not given also you should take it. This you should remember usually, 1 gram per ml. Okay, so density of the water we know that is 1 gram per ml. Now from this two we can calculate the mass of the water. That is what is important. So mass of the water is what then? Tell me. Mass of the water is equal to, we know density is mass by volume. Correct. We have learned that density is mass by volume. So tell me what is mass? Mass is equal to volume into density. So volume into density. So mass of the water is equal to volume, that is 1000 ml, into density of the water, that is 1 gram divided by ml. So this will get cancels off. So you will get the mass as 1000 gram. Understood? Now you have obtained the mass of the water as 1000 gram. From this what you can calculate? The number of moles of the water. If you know the number of moles of the water, okay, if you know the number of moles of the water, you can calculate what? Number of molecules. I have told, whenever they have given molecule and asking you to calculate the number of atoms, what is our strategy? Always the strategy should be calculating the number of molecules. So if you know the number of molecules, then easily you can find out the number of atoms. How? We know for one molecule how many atoms are there. That is called atomicity. So we will calculate the number of molecules, then multiply by atomicity to get the number of atoms. This is my strategy. So right now I know what is the mass of the water. So next I will calculate the number of moles of water. So number of moles of water is equal to how much? Mass in gram divided by molecular mass of the water, that is 18. Correct. Number of moles of water is equal to mass in gram divided by molecular mass of the water. So this value, if you do, this will come around 55.5. This is a standard value. People, they used to remember, we need to remember this for saving the time. Always if they say 1 liter of water, how many number of moles are present in that? 55.5. Always remember like that, because this is not going to change. If they are just mentioning 1 liter, means remaining thing always remains the same. 1000 density will not change, and again you will get 1000 gram, and molecular mass 18 will not change. So always this 55.5 is a fixed value. Okay. So number of moles of the water we have obtained. We know that if number of moles is there, we can calculate the number of molecules. So how do we do that? Listen here. So I am rubbing this. Okay. So we know that 1 mole, how it is related? 1 mole of water molecule will contain, as from our, please listen to our previous videos, 1 mole of any water molecule, how many number of molecules? Avogadro number of water molecules. Correct. Avogadro number of molecules. Now tell me how many moles you have? 55.5. How to convert 1 to 55.5? Multiply by 55.5 on both sides. Correct. So tell me how to do that further. So I can write 55.5 mole of water molecule contains how many water molecules? 55.5 Na water molecules. Correct? So I am not putting the actual values. Just this is an understanding. For 55.5 Na water molecules. Did you get the answer? No. Now I know how many water molecules are there in 1 liter of water. So 1 liter of water we have tried to convert it into number of moles, and corresponding to that I have found out the number of molecules. So this indirectly means that if you take 1 liter of water molecules, always remember it will contain how many water molecules? 55.5 Na water molecules. This you should remember, then it is easy for you to do bigger calculation. So that means 1 liter of water has how many water molecules? Tell me. 55.5 Na water molecules. Na water molecules. Now we will go to one molecule. One molecule has how many atoms? This we have learned it already. So one molecule of water, if I am taking one molecule of water has how many atoms? 3 atoms. How these 3 atoms are coming? We know that one molecule of water means H2O. Correct, H2O. So its atomicity is what? Atomicity. Atomicity represents the number of atoms present in one molecule. So its atomicity is equal to 3. So I know that in one molecule you have 3 atoms. Now how many molecules you have? 55.5 Na molecules. So how many atoms will be there? 55 Na into 3. Correct. One molecule is having 3 atoms. So we will do it in that way. So one molecule has 3 atoms. Now how many molecules you have? 55 Na molecules. So I will multiply by 55.5 Na on both sides. 5 Na. So you can say 55.5 Na molecules of water has how many atoms? 3 times 55.5 into Na atoms. Correct? So suppose they are asking hydrogen atoms, means here atomicity of hydrogen needs to be taken, then it will be 2. If they are asking oxygen, means it will be 1. But here generally they are asking total number of atoms. That is the reason why atomicity I have taken it as 3. Okay. So now tell me what is this value? 55.5 into 3 into Na. So that will come around 166.5 Na atoms. So this will be my answer. So I know that 55 Na molecules of water means how much liter of water is that? This is equal to 1 liter of water. So I have got the answer exactly what they have asked. So they are asking you to calculate the number of atoms present in 1 liter of water. So we know 1 liter of water is 55 Na molecules. How it is getting, that is what I was explaining earlier. So 55 Na molecules of water, that is equal to 1 liter of water. It has an atom, number of atoms is equal to 166.5 into 6.022 into 10 power 23 atoms. You can multiply and get the actual answer. Okay, so I hope you understood. This is very important question for Neet. Suppose they are asking you 2 liter of water for entrance. So if you are remembering this value 166.5 Na, then for 2 liter means what you need to do? Multiply by 2. That's it, nothing else. Understood? So this is the standard way. Okay, thank you. We will go to the next question. Hi students. So next we are going to discuss the problems on vapor density. Okay, I hope you could read the question. Okay, this problem is not related to vapor density, but it is also an important question. Okay, so calculate the number of atoms of chlorine in 2.08 grams of barium chloride. Read the question. So here they are asking you the number of atoms. Correct, they are asking you the number of atoms. Calculate the number of atoms. And what they have given you here, barium chloride. I know this is a molecule or a compound. Whenever they are giving you a compound and asking you the number of atoms, and specifically they are asking you not the total number of atoms, chlorine atoms alone. In that case, we need to apply the concept of atomicity. So tell me what is the method. They have given mass. We know that if mass is given, we need to convert this into number of molecules. Correct. So once you know the number of molecules, what you need to do, we can find the number of atoms of chlorine. How one molecule of chlorine, we will check how many chlorine atoms are there. Then that is called atomicity of chlorine in barium chloride. Then multiply with the number of molecules. So tell me what is the idea. We should first find the number of molecules. So mass is given, we need to find the number of molecules. So we have many methods. We will go by standard method. So what is the molecular mass of barium chloride? First we will find out that. So the molecular mass of BaCl2, barium chloride, that is equal to atomic mass of barium, that is given 137, and chlorine we know 35.5 into 2 since it is Cl2. So if you calculate this, this will come around 208. So this is the molecular mass of barium. Okay, atomic mass unit or unified mass. Okay, now we know this one. So from our fundamental concept we know that 208, correct, gram of BaCl2 contains how many number of molecules? We know that Avogadro number of molecules of barium chloride, correct. This we have learned first. Please, if you are not remembering, please go to mole concept in terms of molecules. Now 208 grams of barium chloride has Avogadro number of molecules, but how much mass is given to you? That is 2.08 gram. Now the question is how to convert 208 to 2.08 gram. Tell me. To convert 208 to 2.08, divide by 100. So 2.08 gram of barium chloride. When you divide on the LHS, do it on same thing on the RHS. So divide by 100. So this will become Na by 100 molecules of barium chloride. Correct? So I got the number of molecules. What is the number of molecules present in 2.08 gram of barium chloride? Na by 100 molecules. Now if I know the number of molecules, what is the next thing to find out? Atomicity of chlorine in barium chloride. Multiply that, you will get the number of atoms of chlorine. Okay. So the next step is what actually? So we calculated the number of molecules. Next we will write down the atomicity of, or first we will do the total atomicity for your understanding, then we will say the atomicity of chlorine. Anything is okay. So we say atomicity of barium chloride. Atomicity of barium chloride. So tell me, atomicity means the total number of atoms of one molecule of barium chloride. One barium and two chlorine. So I say atomicity is 3. Now atomicity of chlorine. Atomicity of chlorine in barium chloride. Tell me, so in one molecule of barium chloride, how many chlorine atoms are there? 2. So I can say the number of atoms of chlorine in 2.08 gram BaCl2 is equal to atomicity of chlorine multiplied by number of molecules of BaCl2. Correct? Atomicity of chlorine multiplied by number of molecules of BaCl2. So atomicity of chlorine we know that is 2, and the number of molecules of BaCl2 in 2.08 gram we also calculated. That is how much actually? Hope you remember, Na by 100. So what will be answer? It will get cut off. So I will get Na by 50 will be my answer. Okay, you can do the exact calculation. 6.022 into 10 power 23 divided by 50 will be the exact answer. You can do it. Okay, so I hope you understood the concept. So we will go to the next question. Okay. Hi students, we will go to the next question. I hope you are able to see the question. Just I will read it. Okay. At STP, 5.6 liters of a gas. Okay, it weighs 8 gram. How much? It weighs 8 gram. Calculate its vapor density. So this is the question. So what is the clue given here? So they are telling 5.6 liters of a gas is weighing 8 gram and they told it is at STP. So what can be done here? We know that at STP 22.4 liters of a gas weigh its molecular weight. Correct. So from that we will start. The clue given here is 5.6 liters of gas has a mass of how much? 8 gram at STP. This is very important at STP. Now, how to convert this into 22.4 liter? Why I am converting this into 22.4 liter? Because that will give me the molecular weight. I can say 22.4 liter of any gas at STP weighs how much? molecular weight. Okay, this is a golden statement. You should remember every time. How it is arrived, we are learning this in our fundamentals. Correct. 22.4 liters of any gas at STP weighs molecular weight. So I should convert this 5.6 to 22.4 liter. So 22.4 liter. What should be done? I should multiply by 4. So 22.4 liter of gas. So when I am multiplying on the LHS by 4, multiply on the RHS also by 4. So multiply by 4 here. So this will become 8 into 4, 32 gram. So what is 32 gram? 32 gram is the molecular weight of the gas. Correct? So 32 gram is the molecular weight of the gas. Now how to find the vapor density? Tell me. We have a relation between vapor density and molecular weight. We have already learned that. Now we will try to see what is that. Okay. So just now we have find out 22.4 liters of the gas is going to weigh 32 gram, that is the molecular weight. We know that vapor density into 2 is molecular weight. Correct. Vapor density times 2 is molecular weight. So what is vapor density then? Vd is equal to molecular weight divided by 2. So molecular weight we calculated, that is 32 divided by 2, and the answer is 16. So the vapor density is 16 in this case. Okay, so I hope you understood how to do this. Sometimes they will give a compound as options which will have a molecular weight of 16, and we need to find out the molecular weight and check it out which is that compound. Anyway they can give it, so this is the standard way of finding it out. Okay, so I hope you understood the question. So we will switch to the next question. Okay, so I hope you could see the new question here. The vapor densities of two gases are in the ratio 1:3. Calculate the molecular masses ratio. Their molecular masses are in the ratio. That is what they are asking. So we say the two gases, let it be gas A and gas B. We don't know. So we assume gas A and gas B. Okay. So they have what they have given you, vapor density of gas A to vapor density of gas B. Its ratio is given as 1/3. Correct? And they are asking you the molecular masses are in the ratio. We know that the standard relationship vapor density into twice gives you the molecular weight. Correct? Now I can write here vapor density is equal to molecular weight divided by 2. Correct? So I can substitute here vapor density of gas A as how I can substitute molecular weight of A by 2 divided by molecular weight of gas B divided by 2. Since 2 is a common factor, we can cancel it out, and we will write it here 1/3. So now tell me what will be the molecular masses ratio. So we can say molecular weight of A to molecular weight of B are in the ratio 1/3. Okay, so I hope you understood the question. We will switch to the next question. Okay. Hi students. So the next topic is one of the very important topic of this chapter. Why I am telling this is, after going through the entire topics of this chapter, most of the students come back saying that, sir, equivalent weight concept is not clear, sir. I have still issues with equivalent weight. So that's the reason why I say this is one of the core topic that is not at all residing in this chapter. It is also extended in other chapters as well, especially in redox reactions and all. Many places in solutions you might have seen some of the methods of calculation of equivalent weight. There I have told that. Here I will explain what is basically equivalent weight. Why we need to learn equivalent weight? There is already molecular weight for a molecule, atomic weight for an atom, everything is there, and formula weight for a ionic compound. All these things are there. Then why we are learning the concept of equivalent weight? This is the first thing we need to understand. Okay. So before I go through the definition, I will explain that scenario, then you will understand it very clearly. Okay, so You might have learned the stoichiometric method, right? We write a balanced chemical equation, and we know how right now how to calculate the amount of products formed. We know how, that is which method we are using. We are using the stoichiometric method, where we are balancing the chemical equation first, then we are finding the stoichiometric ratio, then based on the what concept, stoichiometric concept, we will say 2 mole of this on as per balanced chemical equation gives 1 mole of this thing, correct? But you might have noticed that in all the stoichiometric methods of calculation, we have balanced the chemical equation, correct? Without balancing, if you apply that, it will go to, you will get wrong answer, correct? So that is the I can say the strongest point as well as the weakest point of stoichiometric method. Why I am saying the strongest point means, once you balance the chemical equation, it is very easy then to calculate either the amount, mass of the product formed, or the number of molecules of the product formed, or the volume of the product formed, number of gram atoms or gram molecules, number of moles, anything you can find out, correct? But before that, the main challenge before you is writing the equation and balancing it, correct? So here is where scientists have faced some difficulties actually. So when you write simple reaction where hydrogen reacting with oxygen forming water, or if you have nitrogen reacting with hydrogen forming ammonia, Haber's process, or if it is calcium carbonate decomposition, all these things are simple equations where you can easily write it and balance it out. But there are reactions which are complex in nature. For example, if you have a complex compound K2, FeCN6, something like that. So whenever you have reactions with a complex chemical compound, and if you want to balance it, it may consume a huge amount of time. Also, it is very difficult for a person to predict the products by just seeing, by just writing the equations. There may be other products are also that might be formed. In that case, if you doesn't know the other products that has formed, you may not be able to balance the chemical equation. If you are not able to balance the chemical equation, then you cannot apply stoichiometric method, correct? So at that context, scientists have come up with a next concept. That concept is called equivalence method, or it is called law of equivalence. Okay, this is one of the interesting law for me, because this law states that you don't want to balance a chemical equation. You just need to, I can say even you don't want to write the chemical equation itself. That is the using your application of law of equivalence. Without writing an equation of reactants or products, you will be able to calculate the mass of products, or number of moles of the products, or the number of molecules of the products, or whatever be it. You can do that. Now you feel wondered, right? So you might feel like, sir, then we need a law of equivalence only. Everybody will say like that in the start. Then they start, then where is the challenge or difficulty in applying the law of equivalence? So many students say, sir, stoichiometric method is easy for us, sir. Stoichiometric means we can balance it and we will do it, no issues. Law of equivalence is difficult. Sir, even though that concept is easy, but handling the problems is difficult. The reason for that is, I will say, in the law of equivalence, I will come to that concept. Law of equivalence, we are not using the concept of number of moles. You might have noticed that in stoichiometric method, after balancing the chemical equation, I might have told 2 moles of hydrogen react with 1 mole of oxygen to give 2 mole of water. I might have told that, correct? There I am making use of the concept of number of moles or moles. Here is where the concept is changing. In the law of equivalence, we are not at all using the concept of number of moles. Instead, we are using a concept called number of equivalence, or we say number of gram equivalence. Both are exactly same. Okay, so either we can say number of gram equivalence, or we can say number of equivalence. So it is like sister and brother. Brother is number of moles, means sister is what? Number of equivalence. Okay, stoichiometric, if suppose think like this, stoichiometric method is my father, then law of equivalence is my mother. Okay, brother is then father related to the son, both are related. Okay, but still saying father male, Sun is also male. So we say Sun is number of moles. That concept is used in this concept of stoichiometry. Here mother means we say law of equivalence, and in that what concept needs to be used? Instead of number of moles, we use the concept of number of equivalence or number of gram equivalence. Then similarly you can compare it, you will easily get the answer. That is the other interesting part. Now number of moles, you might have known that. What is number of moles? You will tell here. So number of moles is nothing but weight in gram divided by atom means atomic weight, molecule means molecular weight. That is number of moles. Then I will say number of equivalence is also that only difference is weight in gram divided by, instead of atomic weight or molecular weight, we will introduce the concept of what? Equivalent weight. Understood? So simple, number of equivalence is what? Weight in gram divided by equivalent weight. That's it. Now the question here is, sir, what is equivalent weight, sir? Atomic weight is very easy. It is the weight of an atom. Molecular weight is also very easy. It is the weight of one molecule. Correct? We need to add the atom's weight so that we will get the molecular weight. For example, sir, calcium carbonate. Calcium, the atomic weight is 40. Carbon, the atomic weight is 12. So 40 plus 12. Oxygen, 16 into 3, 48. If you add it, I am getting 100, and 100 is my molecular weight. Sir, very easy to calculate, sir. Correct? Now what is coming to equivalent weight? How you can calculate that? Here is where very important. You cannot easily add the atom's weight and get the equivalent weight. That is not possible. So that's why the challenge here is finding out the equivalent weight. Understood? The challenge in stoichiometric method is balancing the chemical equation, and the challenge in law of equivalence is what? Finding the equivalent weight. Both has challenges. Okay, which challenge is easier for you, you can adapt to that. That's it. But I will always say, if the equation is complex, always apply the law of equivalence. If the equation is simple, always apply the concept of stoichiometry. Okay, now until now I didn't come to the definition of equivalent weight. What is basically equivalent weight? I am coming to that. So I can say equivalent weight is very simple. Equivalent weight of a substance is that weight that will react that will undergo reaction in a chemical reaction. Didn't understand, right? Listen. Suppose you think like you have hydrogen and oxygen forming water. Okay. Now you have taken, for the reaction to happen, you have taken some 5 moles of hydrogen. Okay. So the number of moles is actually what? 5 moles. But can I say that 5 moles will completely undergo reaction? We don't know. We need to balance it. Then we need to say whether limiting reagent is there or not. Based on that only I can say whether that 5 moles will completely undergo reaction or not. Correct. But when I say the equivalent weight of a substance is this much, okay, I can say that equivalent weight of a substance is something that will undergo reaction. Or that is why if you see here the definition, equivalent weight of any substance is that weight which react. It is completely reacting, which react or displace. Liberate means displace, which will react or liberate. From the reaction it will get liberated. That means that is completely involved in the reaction. Okay, which will react or liberate 1 gram of hydrogen. 1 gram of hydrogen is equivalent to what? 11.2 liter of hydrogen gas at STP, or 8 gram of oxygen, or 35.5 gram of chlorine, or 80 gram of bromine, or 127 gram of iodine, or 108 gram of silver, or 1 mole of electron. I understood that. You might not have understood the definition. Listen, very easy, sir. So I will try to explain it so you will get a fair idea. I hope you might have noticed the note down the definition. You can note down it. Now I will try to rub it and I will try to explain this actually so that you will get a fair idea. Okay. So I will just rub it out because this needs more explanation for you to get a clear picture. Otherwise you will always be in doubt. So that's the problem of equivalent weight. Okay, so very simple. Listen here. So you have to say, you have to find out equivalent weight of a substance. You need to find out equivalent weight of a substance. So we are saying the definition of equivalent weight is very simple. Equivalent weight, how will you measure the equivalent weight of a substance? They are telling, by definition, they are telling that equivalent weight is that particular weight that can react with, how much gram of hydrogen? 1 gram of hydrogen. Okay, so during a reaction, you taken some mass, for example 10 gram of a substance you have taken, and during the reaction you have found out that this 10 gram of the substance completely reacted with 1 gram of hydrogen. If 10 gram needs 1 gram of hydrogen, we say this 10 gram as what? My equivalent weight of the substance. Suppose you have taken 25 gram. Initially you have taken 25 gram, okay, but you noticed that 25 gram of the substance reacted with 2 gram of hydrogen, think like that. Then can you tell me this 25 gram as the equivalent weight? No. Why? Because 25 gram of the substance reacted with 2 gram of hydrogen. As per definition, as per understanding, we know that with 1 gram of hydrogen, what is the mass that is reacting? That is my equivalent weight. So I can say 25 gram reacted with 2 gram of hydrogen. Therefore, to convert 2 gram to 1 gram, divide by 2. So I can say 25 by 2, that is 12.5 gram reacted with 1 gram of hydrogen. Then that 12.5 gram is my what weight? Equivalent weight. Understood? Very, very simple. Now, in some other reaction, we say react with or displace. After the reaction, 1 gram of hydrogen is liberated. Then also I can say, if 1 gram is liberated, check out for liberating 1 gram of hydrogen, how much gram of the substance reacted. Then that gram is my equivalent weight. Suppose 2 gram is liberated means, I will first calculate how much gram is reacted, then divide by 2 to get 1 gram. So very simple, equivalent weight of a substance is that weight that will react with 1 gram of hydrogen, or what we say, so 1 gram of hydrogen is equivalent to what at STP? Tell me, 2 gram will occupy 22.4 liter. So 1 gram will occupy how much? 11.2 liters. So we can say in this way also. So if during the experiment you found out that, or in the question they have given that a substance reacted with a hydrogen, and after the reacted with 11.2 liters of hydrogen. So they are saying 8 gram of the substance reacted with 11.2 liter of hydrogen. Then I can clearly say completely reacted means that 8 gram is my equivalent weight. Understood? So next thing, can you say equivalent weight only with respect to hydrogen? No. We can say also with respect to other terms as well. So we can say with respect to chlorine, we say 35.5 gram of chlorine, or I will put here or, so that will make you easier actually for understanding. Okay, so we can say 35.5 gram of chlorine, or we say 8 gram of oxygen, O2. Okay, 8 gram of oxygen, or we can say 108 gram of silver. Okay, or we can say what, 80 gram of bromine. Okay, or during electrolysis we say 1 mole of electron. Okay, now also many students will say, sir, you are always trying to define the equivalent weight of a substance with hydrogen, chlorine, silver, or chlorine, oxygen, silver, or bromine. Why can't we take other elements? The reason for that is, these are compounds, hydrogen, chlorine, oxygen, silver, or bromine. They constitute 80% of the reaction, or they are the major reactions. For example, reaction with oxygen is called oxidation, and reaction with the chlorine and hydrogen, all these gases are present in the atmosphere, and that's the reason why these reactions are usually done in laboratory level, very easy to reproduce. That's the reason why with these gases we are trying to define. You can define with respect to any gas, but commonly used is this one actually. So here, then many students will come and ask me, sir, why you are saying here 35.5 gram of chlorine? How you are getting this value, sir? That is very simple. You should understand that as per the law of equivalence, always I am coming to that. Then only you will understand why I have taken this mass. Okay, as per the law of equivalence, during a reaction, during a chemical reaction, always the number of equivalents of the reactants is equal to the number of equivalents of the product formed. But do you know in stoichiometric method, can I say that number of moles of the reactant is equal to number of moles of the product? No, right? It will not be correct, because different number of moles balances to form different number of moles of products. But as per the law of equivalence, the number of equivalents of the reactants will be equal to the number of equivalents of the product. So if this particular substance is a reactant and think like this particular substance is a product, then the number of equivalents of this substance should be equal to the number of equivalents of this substance. Okay, now listen. So I hope you understand. I am going to explain law of equivalence next. Just I have told this. So here this mass is actually the equivalent mass of these particular gases. That is the reason why this value is coming. For hydrogen 1 gram the equivalent weight, and chlorine we say 35.5 gram is the equivalent weight, and oxygen 8 gram is the equivalent weight. So then you will ask me, sir, how you have calculated that? So please refer to my lectures in expressing the concentration of solution. There I am explaining how to calculate the equivalent weight for different steps. For example, for elements, for compounds, for acids, bases, like that. So I will just explain with one thing actually. For oxygen I can say, so you know oxygen, the atomic mass is 16, correct? So if I want to find the equivalent weight, we know equivalent weight is equal to atomic weight divided by valency factor. So here I know atomic weight is 16. So 16 divided by n factor or valency factor. So for oxygen valency is how much? Valency is 2. So divide by 2. So you will get 8. So that's the reason why 8 gram is coming here. Understood? Now silver, the valency is 1, that's why 108 itself is coming. Fluorine, the valency is 1, that's why atomic weight and equivalent weight are same. Chlorine, the valency is 1, so that's why 35.5 atomic weight is equal to equivalent weight. Hydrogen, you know 1 gram, the valency is 1. Understood? So very easy. So to find the equivalent weight of a substance, what we will do, we will check how much gram of this substance will react with either 1 gram of hydrogen or 35.5 gram of chlorine or 8 gram of oxygen or 108 gram of silver or 80 gram of bromine. Easiest way. Understood? So next we will be introducing you the concept, or in the next slide I will write those calculations of equivalent weight one more time, just formulas alone, not explaining. The detailed explanation along with the questions I have done it in expressing the concentration of solution. You can watch that video, get the complete questions and complete methods of each method and examples you can see. Here I will be next going to explain the concept of law of equivalence. Okay, so I hope you understood the initial introduction. We will come to the next concept, that is law of equivalence. So hi students, so first I am this already I have you might have noted down these formulas, but I am just saying it for my satisfaction as well as to understand the context actually. So these are methods of calculation of equivalent weight, very important. Here I am emphasizing the term calculation, okay, and here also I am emphasizing the term theoretical. So theoretical means you don't want to do any experiments to find out the equivalent weight, but using the formula, just using the formula you can calculate the equivalent weight. These are formulas like that. Understood? So you can see various formulas. First, equivalent weight of an element is equal to atomic weight by valency factor. I am not explaining in detail, that you could see in the other video. Okay, just I am writing, just it is for you to note down the formulas. Now equivalent weight of ions. So if you have an ion, positive ion or negative ion, the method is formula weight of the ion. Why we are saying the term formula weight here? Because ionic compound, we instead of using the term molecular weight, we use the formula weight. That is the reason why the formula weight of the ion divided by valency. Understood? Now, equivalent weight of the ionic compound. If it is an ionic compound, what is the method? What you need to do? Equivalent weight of the cation plus equivalent weight of the anion. You need to add it. Okay. Now, equivalent weight of an acid or a base. So, equivalent weight of an acid means what? Molecular weight divided by basicity. So, in acid, how many H plus is donatable? That is the value of basicity. And equivalent weight of a base is equal to what? Molecular weight by acidity. So, in the term of base means how much OH minus is donatable. That will give you the acidity. Okay. Now, if it is a salt, equivalent weight of the salt is equal to what? Molecular weight divided by total charge on the cation, or very important, I am emphasizing the term or. Either you calculate the total charge on the cation or you calculate the total charge on the anion. Substitute it and divide it, you will get the equivalent weight of the salt. And equivalent weight of an oxidizing or reducing agent. So equivalent weight of an oxidizing agent means molecular weight divided by number of electrons gained. Okay, so I have explained this already in my previous video. What is an oxidizing agent, what is a reducing agent, so what is oxidation, reduction, everything I have explained, just explaining the formula. Okay, so equivalent weight of an oxidizing or reducing agent. Oxidizing agent means molecular weight by number of electrons gained, and equivalent weight of a reducing agent is equal to molecular weight divided by number of electrons lost. Understood? So these are 6 formulas that help you to calculate the equivalent weight of a particular substance theoretically. Understood? Then you will ask me one question, sir, then why we learned, sir, in our definitions, sir, equivalent weight of a substance is that weight that will react with 1 gram of hydrogen, 35.5 gram of chlorine, 108 gram of silver. Why we need that? That is to calculate the equivalent weight experimentally, because there during the experiment we will say you need to take just 35.5 gram of chlorine and determine how much gram of other reactant has reacted. So with the 35.5 gram of chlorine, how much gram has reacted, then that gram, that is reacted gram, will give me the equivalent weight of that substance. Understood? So this is the easiest way. Why I am saying, why then experimental method is required? Because you are discovering some new elements. You don't know anything about that. Then the best way to calculate the equivalent weight is take that element and try to react with the chlorine. Then that element says, sir, I will not react with the chlorine. Then okay, no issues, react with oxygen. We have different replacements are there. So chlorine is there, then take oxygen. Then take how much gram of oxygen? 8 gram of oxygen. Then find out with 8 gram of oxygen how much gram of this element is reacting. Then that mass is my equivalent weight. Understood? That is the experimental way where you are determining the equivalent weight. This is the theoretical way of calculating the equivalent weight. So question they can be created in any way. They can say that in an experiment like that they can create question from the other method, that is experimental method. They can also create the question from the theoretical method also. So please understand that one is theoretical and one is experimental. Don't get confused. Very important. Okay. So theoretical just completed. Next we will go to our experimental methods. Then we will go to the concept of law of equivalence. Okay. Hi students. So until now we were discussing the theoretical calculations or method or formulas by which you could calculate equivalent weight. Now we are coming to the experimental methods for determining the equivalent weight. Very important. Questions used to come from this area. Okay. So what is the first experimental method? Okay, just I will explain that, understand the scenario, then we will come to the concept. Very simple. You have discovered an element, think like this. Okay, you don't know, you have some mass of that element, but you don't know what is that element, nothing you don't know. Okay, in that case what you need to do, how to find the equivalent weight of that element? The thing is very simple. Take that element, try to react with oxygen if it is reacting with oxygen. So reacting with oxygen means oxidation. Then if it is not, what you need to do, then react with hydrogen. Why I am taking hydrogen, oxygen, chlorine, all these elements are very much reactive in nature. So first I am going to describe the method called hydrogen displacement method. Okay, now take that element. Okay, suppose if it reacts with hydrogen, then using hydrogen displacement method we can determine its equivalent weight. What you should do? You need to take hydrogen, 1 gram of hydrogen you need to take. Okay, that should be very important. Take 1 gram of hydrogen and take the element. Take that new element, you don't know. You have measured its mass also. So on measuring, you have taken something like 230 gram or 250, anything you can take. 250 gram you have taken. And you have taken 1 gram hydrogen. Now try to react this 1 gram hydrogen with the 250 gram of this element. Okay, then identify how much amount of, after the reaction, how much amount of the new element is left behind. Suppose you think like 250 gram you have taken, okay, and after the reaction you have 230 gram left behind. That you can take it and okay, after measuring you understood 230 gram is left behind. Now tell me how much gram has underwent reaction. 250 minus 230, that is 20 gram has reacted with 1 gram of hydrogen. I know, as per my understanding, the mass of the substance or mass of the element which react with 1 gram of hydrogen is my equivalent weight. Now tell me what will be the equivalent weight of the new element. It will be 20 gram. As easy as that. Understood? So this is the way we used to find the equivalent weight experimentally. Now look at here. I have also explained the same stuff. So equivalent weight of the element is that mass which will react with 1 gram hydrogen, and this method is called hydrogen displacement method. Usually this method is employed for metals. Why? Because the metals can displace hydrogen. So those elements which can evolve or displace hydrogen from acids, for those we usually prefer hydrogen displacement methods. Okay, now by formula, or this is a formula that is derived. I can tell how this derivation is coming. Just now you understand equivalent weight of the metal by hydrogen displacement method is equal to weight of the metal. You might, in our previous example, 250 gram of the metal was taken. So you can substitute there 250 gram divided by weight of the hydrogen gas displaced. So how much gram of hydrogen gas is evolved, that you can place it here. If you divide that ratio, you will get the equivalent weight of the metal. Very simple. Hi students, so next we are going to define or the experimental methods for determining the equivalent weight. Second method we are going to say. Okay, so this is the second method. First method we already told, that is hydrogen displacement method. So in the second method the name is oxide formation method. So very simple. So first I will tell the idea. Again, think like you have an element you have discovered, you know the mass of that element, you have measured it. So say again 250 gram, okay, it's a new element, okay, 250 gram of that new element you have taken. First you tried to react with hydrogen. You understood that it does not have any reaction with hydrogen. So what you have taken, as per the next definition of equivalent weight, you have taken oxygen. Now what you have done, you reacted this element with oxygen, so that what will happen, that element will combine with oxygen to form element oxide, correct? So you now know initial weight of the element. Now you have reacted with oxygen and you know the final weight of the oxide, correct? So final weight of the oxide also you know. Now how to calculate the weight of oxygen, how much amount of oxygen has reacted? What you need to do, mass of the oxygen that has reacted is equal to mass of the oxide that is formed minus mass of the element you have taken, correct? That will be the mass of the oxygen, because element combines with oxygen giving elemental oxide. So if you know the mass of the element and if you know the mass of the oxide, oxygen will be mass of the oxide minus mass of the element, correct? So then thereafter what is the thing, equivalent weight of the element is equal to weight of the element that you have taken, then weight of the oxygen that you have determined by this method, multiply by 8. This is called oxide formation method. So from this you will get the equivalent weight of the element. Either you can directly apply the formula and get the answer, or sometimes directly the question statement will say 350 gram. Maybe I am just saying as an example for your understanding. Say 350 gram of an element reacted with 16 gram of oxygen. Calculate the equivalent weight of the element. So I know 350 gram is reacting with how much gram of the element, how much gram of oxygen? 16 gram. So as per my definition, equivalent weight of the element is that mass which will react with how much gram of oxygen? 8 gram of oxygen. So 350 gram is reacting with 16 gram means 8 gram will react with how much? 350 divided by 2, correct? So it will come around 175. Then 175 gram will be my equivalent weight. You can do it like that also, that is depending upon the question. Sometimes they will give mass of the oxide that is formed and mass of the element you have initially taken. Then you need to apply mass of the oxygen by this method and apply equivalent weight of the element is equal to weight of the element by weight of the oxygen into 8. Weight of the element means how much mass of the element you have taken. Weight of the oxygen means how much oxygen it has reacted with. Multiply by 8. This will give you the equivalent weight of the element. I hope you understood oxide formation. Very simple. Take the element, react with oxygen, form the oxide. Note the mass to calculate the mass of the oxygen. Initially you have taken the element, so you know the weight of that element. Final product is also before you, that is the oxide is also in front of you. Measure it, find out the mass, then subtract it. It will give you the mass of oxygen. Then substitute in the formula, you will get the answer. That's it. I hope you understood the oxide formation method. Now we will go to the third method. Okay. Hi students. So here we are going to discuss the third method for experimentally calculating the equivalent weight. So that method is called chloride formation method. So from the name itself you might have understood. Very simple. Again I will say an intro. Please listen to that. You have a metal or an element. Okay. You know its mass but you don't know the equivalent weight. So you have just measured using a weighing balance and you understood its mass is 200. Okay. Now you have tried to react with hydrogen, there is no reaction. Tried to react with oxygen, no reaction. You have now taken chlorine. Now with chlorine you understood there is a reaction. Now with chlorine I can calculate what? The equivalent weight of the element. How? Take that element which is the weighted element, how much it is? 200 gram. Now what you need to do? React it with chlorine so that it will form elemental chloride. So you know the initial mass of the element, that is 200 gram. Now you have got the elemental chloride also. Note down its weights or measure its weight. Now what is the mass of chlorine then? I can say mass of the elemental chloride minus mass of the element initially noted down. So you will get mass of the chlorine. Now substitute here equivalent weight of the element is equal to weight of the element initially taken divided by weight of the chlorine that you have calculated by this method. Formula, then multiply by 35.5, you will get the equivalent weight of the element. Understood? This is one way of doing it. Other way, earlier I have told in question paper they may say 200 gram of the element reacted with 71 gram of chlorine. So as per my definition I know that equivalent weight is that weight, is that mass which will react with how much gram of chlorine? 35.5 gram of chlorine. So as per my statement 200 gram reacted with 71 gram. Now 71 you divide by 2 it will become 35.5. So divide on the left side also it will become 100 gram. Then I can say 100 gram is the equivalent weight of that particular element. Like that also they can ask. So anyway this is called the third method. It is called chloride formation method. Now you might have understood why we have taken hydrogen, oxygen, chloride. All these elements are highly reactive. That's why any new element is discovered, we will first check with whether these element, the new element have reaction with any of these basic elements. Then it is very easy to find out the equivalent weight. I hope you understood the concept. We will start our problems also, don't worry, after this theory session. Okay. So hi students, we have the next method for determining the equivalent weight, that is experimental method, that is through electrolysis. This you will learn more clearly in your chapter electrochemistry. Okay, that is there in the +2. So by electrolysis the formula is W1 by W2 is equal to E1 by E2. What is W1 here? Here W1 and W2 are the deposited weight of metals at electrodes. We know there are electrodes, anode and cathode will be there. So W1 and W2 represents the deposited weight of the anode or that particular element at anode and cathode. So, and what is E1 and E2? E1 and E2 represents its corresponding equivalent weight. So this will be more, if you want to understand more on this can be understood more through a problem. But the concept here is always the ratio of equivalent weights, E1 and E2 of those two elements will be, this equivalent weights ratio will be proportional to the mass of that elements deposited at anode and cathode. So that's the reason why W1 and W2, which represents the mass of the elements deposited at anode and cathode, that ratio will be similar to, or it will give you the ratio of equivalent weights of that respective elements. So please remember, W1 by W2 is equal to E1 by E2. This is, the method is called electrolysis method. So I have tried to explain around 4 methods. There are other methods also, but these 4 are what is very important actually for exams. So I am concluding here. Now we have learned the concept like what is equivalent weight, understood, and you have learned how to find the equivalent weight of various elements, compounds, acids, everything. Now you have also seen how to find out the equivalent weight of various elements through experimentally, that also we have learned. Now we know how to calculate the equivalent weight. Next we will go into the concept of gram equivalence. Okay, so first I will draw a similarity between what is called stoichiometric method and law of equivalence. We will compare it and then we will go into the concept of law of equivalence, chemical equivalence. Okay, I hope you understood clearly. Any doubt, please feel free to get back. Okay. Hi students, next we are going to compare the stoichiometric method versus law of equivalence method. This is very important. So if you are able to understand the difference between these two, so you will clearly understand why this method is required and what is the advantage of this method, what are the disadvantages of these methods. Okay, so I will try to compare this. I have already written the comparisons, so if you want you can take a snapshot and note down. Okay, so let's compare it. It's very easy actually. So starting with a reaction. So tell me, first you have written the reaction. What is the most important thing when you come to the stoichiometric method? The first and foremost step is balancing the chemical reaction. Very, very important. So a balanced chemical equation is required mandatorily. In which one? Stoichiometric method. But in law of chemical equivalence, balancing of chemical equation is not required. That means you don't want even the equation itself, actually speaking, that we will come to it. Okay, so just understand, balancing of chemical equation is not at all required. Now, second point. So in stoichiometric method, what is the tool you are using for proceeding? So the tool you are using here is number of moles is calculated and used in this method. We have using number of moles. Understood? Number of moles. What is number of moles? Weight in gram divided by molecular weight. If it is a molecule, we say molecular weight. If it is an atom, we say atomic weight. But we know in reactions, usually molecules will take part. Okay. So we say weight in gram divided by molecular weight. That is the number of moles. So number of moles is calculated and used in this method. Okay. Now coming to law of chemical equivalence. Similar to number of moles, here what is there? We are calculating number of equivalents. Very, very important term, number of equivalents. So this either some people may say number of gram equivalents. That is also correct. Actually speaking, we should say number of gram moles. Why? Because moles is weight in gram divided by molecular mass. So it is weight in gram. So clearly speaking, it should be number of gram moles. But we used to say moles. Okay. And similarly here also tell me number of equivalents will be what actually? Similar to number of moles, it is weight in gram divided by what? Instead of molecular weight, we used to say equivalent weight. So since it is weight in gram, some people say instead of number of equivalents, they say number of gram equivalents. Understood? So that is the only thing. So here number of moles is calculated and used in this method, and here number of equivalents is calculated and used in this method. And third and foremost point, that is what is important. Third point, the number of moles used in this reaction may or may not be same for the reactant and product. It depends on the stoichiometric ratio. Number of moles used in the reaction may or may not be same for reactant and product. It depends upon the stoichiometric ratio. So what does that mean actually? So you have taken 5 moles of A and 6 moles of B. Can you say reactant and product formed will be always the same number of moles? No, we know that depends upon the stoichiometric ratio. Suppose the stoichiometric ratio is 1:1:1. Then I can say 1 mole of A gives 1 mole of B. Suppose the stoichiometric ratio is 1:2. Then I can say 1 mole of A has given 2 mole of B. Understood? So I can say it may or may not be same. It depends upon what? Stoichiometric ratio. Very, very, very important. Now, in law of chemical equivalence, listen, the number of equivalents used in the reaction will be same for reactant and product. That means if you have a reaction A, B, I can say the number of equivalents of A will be equal to number of equivalents of B. Then there is no stoichiometric ratio or nothing. Always the number of equivalents of the reactant and the product will be the same. That is a core point or the most important point. Okay, the number of, that is what is law of chemical equivalence actually. Law of chemical equivalence states that the number of equivalents or the number of equivalents of the reactants as well as the number of equivalents of the product formed will always be the same. Understood? So that's why the number of equivalents used in the reaction will be same for both reactant and product. I know that this is very little bit hard to digest. Sir, how it is becoming same? I will prove it mathematically, or I will show with an equation and I will prove that number of moles will vary, that you can imagine, correct? And I will show that the number of equivalents will remain the same for reactant and product. Okay. Yes, students, so here I am giving 2 more differences that we have already told, but you can note it down as a difference so that it will register your mind. Okay. So 2 more difference here is, first you can say in stoichiometric method, it employs molecular weight or atomic weight for number of moles calculation, correct? Number of moles is equal to weight in gram by molecular weight or atomic weight. So we can say it employs molecular weight as the main concept. Now here it employs equivalent weight. We know how to calculate the equivalent weight. So it employs equivalent weight for the calculation of what? Number of equivalents. We know number of moles and number of equivalents are like brother and sister, correct? So it employs equivalent weight for number of equivalents calculation. So how you do that? Number of moles is equal to weight in gram divided by molecular weight or atomic weight. So number of equivalents is equal to same. You don't want to remember anything extra. Here also weight in gram, but instead of molecular weight or atomic weight, since it is equivalence, we say equivalent weight. That's it. Okay. So very simple. So I hope with this I have tried to put out all the differences between stoichiometric method and law of chemical equivalence. Now we will go into detail what is law of chemical equivalence and we will try to understand that. Okay. Then we will go to the problems. Hi students, so this is one of the very important video I have kept VIMP, so it stands for very important. So here I am explaining the law of chemical equivalence or law of equivalence, both are correct. So listen here, so first I will read the statement, you are also knowing it. According to the law of chemical equivalence or law of equivalence, the number of gram equivalents of the reactant reacted and the number of gram equivalents of the product formed will always remains the same. That means the number of gram equivalents of the reactant will be equal to the number of gram equivalents of the product. So I am again saying, don't get confused by the term gram equivalence. It is same as number of equivalents. Number of gram equivalents is same as number of equivalents. I have told you, right, how it is coming. Number of gram equivalents, how it is coming. Weight in gram by equivalent weight. Since it is weight in gram, we are saying number of gram equivalents. Then you can ask me, sir, it should be number of gram moles, right? Correct, it should be number of gram moles. But for convenience, we are speaking it as number of moles. Because number of moles is weight in gram divided by molecular weight. Okay, so here I have taken an example A, B, C, D. So here A and B are reactants and C and D are the products. And please believe this equation is not balanced. Okay, it is not required. So not balanced. Not balanced. Very, very important. It is not required. If it is balanced also, no issues. We don't have any dependency with the stoichiometric ratio. So we are not worried about it. So if it is not balanced also, no issues. So say A moles of A plus B moles of B reacted to give C moles of C and D moles of D. Okay, now as per, if you apply the law of chemical equivalence, what I can say, the number of equivalents of A or the number of gram equivalents of A will be equal to the number of gram equivalents of B, and which is equal to the number of gram equivalents of C, and which is equal to number of gram equivalents of D. Very easy, right? Okay. So just you need to apply it. Suppose in exam they are asking, okay, tell me how 5 moles of A given how many moles of D. Then I can say, applying the law of chemical equivalence, the number of equivalents of A is equal to number of equivalents of D. Then do it. That's it. I will explain you how to do those calculations and everything. We are going into that only. So I hope you understood the law of chemical equivalence. Please remember, it's very easy. Equation should not be balanced, or it can be balanced, but we are not worried about that. Only thing to remember here is the number of equivalents of reactants is equal to the number of equivalents of the products. So number of equivalents of A is equal to number of equivalents of B is equal to number of equivalents of C is equal to number of equivalents of D. That's it. How number of equivalents are calculated? Number of equivalents is equal to weight in gram divided by equivalent weight. That's it. Okay, so next we will do problems on law of chemical equivalence. Okay, so I hope you understood the concept. There is nothing as a concept, you can just, okay, now I need to prove also. Now I need to prove before you how this is remaining the same. That I will show you. Okay. Hi students, so this is one of the most important video you should see actually, because this you should not miss it out, because this explains the proof for law of chemical equivalence. Because many students will say, sir, even though you told that in law of equivalence the number of equivalents that is used in the reaction for reactants and products are remaining the same, but we cannot believe that. But stoichiometric concept we can easily believe it actually, because we can easily see from our reactions 1 mole of A reacting with 2 mole of B. So if so, 3 mole of B will react with 6 mole, like that we can easily believe. But for law of equivalence, sir, we can't believe it. Sir, please help me in overcoming that trouble. So this is that particular video that will help you in overcoming that trouble, because you can see the actual calculation and can see the number of equivalents are remaining the same. This you can employ for any equations, it will remain the same. Understood? So that is the powerful nature of this law of chemical equivalence. Okay, so I will come with an equation. So you have an equation where sulfuric acid reacting with sodium hydroxide, acid base reaction. We know it's a salt formation, Na2SO4 plus 2H2O. So first of all, I will use the stoichiometric method. So in stoichiometric method, what I should do? I should balance this equation. So I have spent my effort and I have balanced the chemical equation by putting 2 here and by putting 2 here. So I have balanced the chemical equation now, because balancing the chemical equation is the first and foremost step in stoichiometric method. Okay, so I have balanced it. Now what is given to you? Now this is just a balancing. Please remember my chicken biryani story. I know how to prepare. I know for preparing a chicken biryani, I minimum one masala packet, 1 kg rice and 1 chicken piece is required. That is my stoichiometric ratio. Now to actually prepare this, or to actually proceed with the reaction, what is given to you? So accidentally they have given 1 mole of A is given to you. Okay, 1 mole of A is given, very important, given quantity, and 2 mole of NaOH is given. Okay, so as per stoichiometric ratio also, I know that 1 mole of H2SO4 needs 2 mole of NaOH. So you are also given 1 mole of NaOH and 2 mole of 1 mole of H2SO4 and 2 mole of NaOH. So here itself you can see the number of moles given itself is varying actually. And please listen, this 1 mole of H2SO4 and 2 mole of NaOH, you can see the product formed is what? We know that 1 mole of H2SO4 and 2 mole of NaOH needed produces 1 mole of Na2SO4. So the product formed will be 1 mole of Na2SO4 and 2 mole of water. So from this itself you can understand that the given number of moles is differing, correct? And based on that the product formed is also, the number of moles are differing. That is called 1, 2, 1, 2. So that means the number of moles formed will be, may be different, or it can be same when every stoichiometric coefficient ratio will be 1:1:1:1, then it will remain the same, correct? So otherwise we can say that the number of moles may or may not be the same. It depends upon what? The stoichiometric ratio. Here the stoichiometric ratio is 1:2:1:2. So that's the reason why the number of moles are differing in nature. Okay, so this is the way with which we are calculating the product formation. 1 mole of Na2SO4 is formed and 2 mole of H2O is formed. Now we are coming to the law of chemical equivalence. What I need to prove before you is, for any reaction or this reaction also, the number of equivalents of this is equal to number of equivalents of this is equal to number of equivalents of this is equal to number of equivalents of this. This is what I want to prove. Now take it, we will do it one by one. So first we are taking is H2SO4. Okay, so the number of equivalents of H2SO4 is equal to, please remember the formula, number of equivalents is equal to weight in gram divided by equivalent weight. What is the weight in gram that is given to you? How much is given to you for proceeding with the reaction? They have given you 1 mole of H2SO4. 1 mole of H2SO4 is given to you. So what is the weight in gram of 1 mole of H2SO4? I know 1 mole of H2SO4 has a mass equal to molecular weight. So that's why 98 gram, 98 is substituted here. Divided by equivalent weight. How can you calculate the equivalent weight of an acid? You already know equivalent weight of an acid is equal to molecular weight divided by basicity. Basicity is the number of replaceable hydrogen. So equivalent weight is equal to molecular weight, that is 98, divided by basicity. Basicity is 2. Why? Because H2SO4, 2 hydrogens are replaceable. So 98 by 2 I am substituting. So this will get cancels off and 2 will come in the numerator. That's why I can say number of equivalents of H2SO4 used in the reaction is 2. Now what I need to prove, for other reactant and the product formed also, they should have the same number of equivalents. Now we will go to the number of equivalents of NaOH. So the number of equivalents of NaOH is equal to weight in gram divided by equivalent weight, same formula. So what is weight in gram? Weight in gram is what is given to you. So given to you is what actually? 2 moles of NaOH is given to you. So tell me, 1 mole of NaOH has a mass equal to molecular weight. NaOH means 23 plus 16 plus 1, that is 40. So 2 moles means 2 into 40. That's why I have written 2 into 40. Okay. Divided by equivalent weight. Equivalent weight is nothing but again molecular weight divided by acidity, because it is a base. So molecular weight is what? 40 divided by acidity. Acidity means number of replaceable OH minus. So I know that NaOH has 1 OH minus as replaceable. So I will divide by 1. Okay, so this becomes clear for you. 40 by 1. This 40 cancels, and again the number of equivalents is equal to 2. Again it is 2. Understood? Now we will go to Na2SO4. That is a salt that is formed. So the number of equivalents of Na2SO4, you know that again the formula is weight in gram by equivalent weight. So what is weight in gram? So I know that how much amount of Na2SO4 is formed actually. I know that 1 mole of Na2SO4 is formed. So 1 mole of Na2SO4 is formed means, tell me what is the weight in gram of 1 Na2SO4? 2Na. 2Na means 23 into 2. Sulfur 32. 16 into 4, 64 oxygen. So you will get 142. Now equivalent weight of a salt, how you can do that? Molecular weight divided by total charge on the cation or the total charge on the anion. So here we know that Na2SO4 when dissociate, it will dissociate as 2Na plus and SO4 2 minus. So 2Na plus means what is the total charge? 2 times plus charge. So Na plus 2Na plus is there. So plus 1 plus 1. So totally 2. Or you can take SO4 2 minus. Total charge on the cation or total charge on the anion. So 2 minus, again answer is 2. So I can put it here, molecular weight divided by total charge on the anion or cation, that is 2. So this will cancel off, and again the number of equivalents is equal to 2. Now last one, the number of equivalents of water. So I know that how much amount of water is formed? 2 mole of water is formed. So weight in gram is what? 18 is the molecular weight of 1 mole of water. So 2 mole means 18 into 2, 36. So 36 divided by equivalent weight of the water. So how water will dissociate? You know that 2H plus, correct, H2O, how it dissociates? 2H plus and O2 2 minus. So total charge on the anion or cation, or either you can do it in that way or you can consider water as an acid. So tell me how much replaceable hydrogens are there? 2 hydrogens. So its basicity is 2. So I can say molecular weight 36 divided by basicity, that is 2. So cancels off and you will get again 2. So what does this mean? So you could see all are highlighted in red color. The number of equivalents is remaining the same, whether that is reactant or it is product. The number of equivalents remains the same. This is the advantage of law of chemical equivalence. So I hope this you can believe this as a proof for your mind to understand that the law of equivalence, the number of equivalents will remain the same irrespective of whether it is a reactant or the product. Now we will start doing the question, then you will get slowly that confidence. Okay. So in this proof I have given you an equation, right? So in our questions without even equations I will show you how to calculate the different stuffs by applying the law of chemical equivalence. Okay, so I hope you understood. So please take a snapshot or note down all these things. This will help you in further understanding the questions. Thank you. Hi students, I hope you could see a problem here. Okay, I hope it is visible to you. So this problem is based on the law of equivalence. So just read the question. Okay, I will read for you. 2 gram of a base whose equivalent weight is 40 reacts with 3 gram of an acid. Calculate the equivalent weight of the acid. Correct. So until now you have seen equations explicitly saying what is an acid or what is the base used in the reaction. But here you could see they are just mentioning here it is a base and it is an acid, nothing else. So what we can say here, we know generally acid plus base react to form salt. This is what we know, correct? But do you know which acid it is, which base it is? Nothing we don't know, correct? So what we need to apply here to calculate the equivalent weight, we will apply the law of chemical equivalence. So we can say on applying the law of chemical equivalence, what you can say, tell me. So I can say on applying the law of chemical equivalence, I can say the number of equivalents of the acid is equal to number of equivalents of the base, and which will be equal to the number of equivalents of the salt. But here in the question they are not mentioning anything about the salt. So I want to restrict with acid and base, or these two are the terms to be related here. So I can say the number of equivalents of acid is equal to the number of equivalents of base. Correct? I have written here. Now tell me what is number of equivalents of an acid. We know the formula, it is similar to number of moles. I have teach you. So number of equivalents is equal to weight in gram divided by equivalent weight. So I can write weight in gram of the acid is divided by, what you need to say, weight in gram of the acid divided by equivalent weight of the acid. Correct? So this will be equal to what? Number of equivalents of the base. Tell me number of equivalents of the base. Similarly we can write weight in gram of the base divided by equivalent weight of the base. Correct? Now what you need to do, you just need to substitute here. So I will just rub here so that you can directly apply it and get the answers. Okay. So very easy basically this method. So tell me weight in gram of the acid. So they have told 2 gram of a base whose equivalent weight is 40 react with 3 gram of acid. They mentioned the weight in gram of the acid. So I will substitute 3 divided by equivalent weight of the acid. That is what they are asking you to calculate. So I will keep it like equivalent weight of the acid. We need to calculate that. Equal to number of weight in gram of the base that they have mentioned 2 grams. So I substitute 2 here divided by equivalent weight of the base. That is also they have mentioned. How much they are telling? Equivalent weight base whose equivalent weight is 40. So I will substitute here 40. So I can cross multiply this to get the correct answer. So how will you cross multiply? So just to see here, I will cross multiply in such a way. So the equivalent weight of the acid is equal to 2 divided by 40. Okay. So I am taking this 2 here. So I can say 2 into equivalent weight of the acid is equal to 40 into 3. Okay, I hope you remember these mathematics in your lower classes. So what is the equivalent weight of the acid from this? So equivalent weight of the acid is equal to 40 into 3 divided by 2. So it will come around to 20 into 3, that is 60. Understood? So you could see from here how powerful the law of chemical equivalence is. Very easy to find out. Okay. So similarly we will do other questions as well. So I hope you understood this problem. Hi students. So next we are going to discuss a problem on law of chemical equivalence. So it's a simple question, but I am again showing you how to apply the law of chemical equivalence. So we will verify with both methods. Okay. So just read the question. Calculate the mass of magnesium oxide produced when 1 mole of magnesium carbonate decomposed. No equation, nothing is given. Okay. We don't need any equation if you apply the law of chemical equivalence. Okay. So I know that magnesium carbonate is undergoing decomposition. Okay. So and what you need to understand, what is formed? Magnesium oxide is formed. We just need to know these two things. Okay, so on applying law of chemical equivalence, what we can say, the number of equivalents of magnesium carbonate should be equal to what? The number of equivalents of magnesium oxide. Correct. So tell me how to calculate the number of equivalents of magnesium carbonate. We know that the number of equivalents is equal to weight in gram. What is weight in gram? Given. So what is given to you? Given to you is 1 mole of magnesium carbonate. Its weight is equal to 84 gram. So I have calculated that here. So 1 mole means it is the molecular mass. That's why 24 plus 12 plus 48. 48 plus 12 is 60 plus 24, 84. Okay, 84 divided by number of equivalents, weight in gram, divided by equivalent weight. Equivalent weight is equal to molecular weight, that is 84, divided by. So here magnesium carbonate, it is a salt actually. So I can say Mg2 plus CO3 2 minus. So I can take either the total charge of the cation or total charge of the anion. So that is 2. So 84 by 2. So this 2 will get cancels off and you will get 2 here. Okay. Now here number of equivalents of magnesium oxide. Again weight in gram of the magnesium oxide. That is what they are asking you to calculate, mass of magnesium oxide. So weight in gram of the magnesium oxide divided by equivalent weight of magnesium oxide. Equivalent weight of magnesium oxide is equal to molecular weight, that is magnesium 24 plus 16, that is 24 plus 16 divided by magnesium oxide. Again this is it's an oxide, so what you need to do, magnesium on splitting gives Mg2 plus and O2 2 minus. So total charge of the cation or anion, so it will come as 2. So I can say now 2 is equal to this W gram by this, you adding, it will become 40 and 2 will come on the numerator into 2 and these 2 will get cancels off. So weight in gram is equal to 40 W gram. So that is weight in gram of the magnesium oxide is equal to 40. We got the answer. You feel like okay, you need to do something, correct? But this type question I will always prefer stoichiometric method because very little to do. You don't, the equation is very simple. Now applying stoichiometry, we know that now this equation is balanced. MgCO3 giving MgO plus CO2. It's a balanced chemical equation. I know that as per stoichiometric ratio, 1 mole of MgCO3 gives rise to 1 mole of MgO. Now very simple, what they are asking you, calculate the mass of MgO produced when 1 mole of MgCO3 decomposed. So given is 1 mole of MgCO3. Now tell me, if given is 1 mole MgCO3, how much mole of MgO will be formed? 1 mole of MgO will be formed based on stoichiometry. Now tell me 1 mole of MgO means what is its mass in grams? I know that 1 mole is equal to molecular mass. So MgO means Mg 24 plus O is 16, 24 plus 16, 40. So I will get the same answer, 40 there. Understood? So it depends upon the situation. So these like equations where you can explicitly write and balance it, always apply stoichiometric method. But there are equations which are very complex where balancing is horror. In that case, you should apply the law of equivalence, law of chemical equivalence. But I hope you understood how to do this. Clear? So we will go to the next question. Okay. Hi students, we will go with the next problem. So just read it out. If 2.4 gram of a metal displays 1.12 liter hydrogen at normal temperature and pressure, then calculate the equivalent weight of the metal. So again you know metal and hydrogen is coming. So what is the method you need to apply here? Hydrogen displacement method, correct. So tell me what is the equivalent weight of the metal as per hydrogen displacement method? Equivalent weight of the metal as per hydrogen displacement method is equal to, tell me the formula. So we know that weight of the metal divided by what? Weight of the hydrogen into 1. Okay. Now here weight of the metal, it is very clearly given 2.4 gram. So that I can substitute. But what about weight of hydrogen? They have given volume of the hydrogen. Weight of the hydrogen is not given. Okay. So and they are mentioning it as normal temperature and pressure. So it is NTP. So STP or NTP, what is the basic difference? STP we are telling the pressure in terms of bar, 1 bar. NTP we say the pressure in terms of atmosphere, that is 1 atmosphere. At both STP or NTP, the volume occupied by 1 mole of any particular gas will be equal to 22.4 liter. So we will make use of that. So we know that, what we know, 22.4 liter of hydrogen gas will weigh how much? Molecular weight, that is 2 gram at NTP, normal temperature and pressure. Now tell me, you need to convert this 22.4 liter to how much? 1.12 liter. Then you will get the mass of the hydrogen, correct? So how you can do that? Easiest way is divide by 2 first. So dividing by 2. So if you divide by 2, this will become 11.2 liter of hydrogen gas will have a weight of 1 gram at NTP. So dividing by 2 on both sides, correct. Now it is very easy. 11.2 it can be easily converted to 1.12. What you need to do? Divide by 10. So divide by 10 on both sides, it will become 1.12 liter of hydrogen gas will have a mass. Divide by 10, this will become 0.1 gram at NTP. Now I got the mass of hydrogen. So if I am applying here, what is the weight of the metal? Weight of the metal is 2.4 gram. So 2.4 divided by weight of the hydrogen. Weight of the hydrogen, 1.12 liter of hydrogen gas will have a weight of 0.1 gram. So 0.1 gram I am applying here. So 0.1 is nothing but what? 1 by 10. So this will become 24. So I can say equivalent weight of the metal is equal to 24. This is how we will apply hydrogen displacement method, because they are talking about metal and hydrogen. So it's easily we can understand it is hydrogen displacement method to be applied to get the equivalent weight of the metal. So I hope you understood the question. So we will go with the next question. Okay. Hi students. So you could see a new question here. Just go through the question. The oxide of a metal has 32% oxygen. Calculate the equivalent weight of the metal. Okay. So they are telling oxide of a metal. So surely this metal might have reacted with oxygen. So surely what method we need to employ here? Oxide formation method. Correct. So what is the meaning of that? The oxide of a metal has 32% oxygen. That means 32, you know that this is mass percentage, correct? So I can say 32 gram of oxygen is present in 100 gram of what? 100 gram of metal oxide, correct? That is the meaning of that. Now from this what you can say, weight of the metal oxide is equal to how much? 100 gram. Now weight of the oxygen is equal to 32 gram. Now can you tell me what is the weight of the metal then? Weight of the metal is equal to, tell me how much? Metal is equal to metal oxide mass minus weight of the oxygen, that is 32, and it will come around 68 gram. Now how to calculate the equivalent weight of the metal? So equivalent weight of the metal is equal to, tell me, what is the formula? So you know that equivalent weight of the metal is equal to, so you can apply the same thing. So what is that? Weight of the metal. So weight of the metal is how much? 68, correct? And weight of the oxygen is 32 multiplied by 8, correct? Weight of the metal divided by weight of the element divided by weight of the oxygen multiplied by 8 will give me the equivalent weight of the metal. So I know it is 8 into 4, it will come around, and if you divide it, this will become 2, if it will become 34 by 2, and further if you do, this will become 17. So I know that the equivalent weight of the metal is equal to how much? 17. So I hope you are understanding the method and why I have employed oxide formation method here, because they are talking about metal oxide of a metal. Understood? So like this we can do many questions. So this is just foundation. We will give you more questions in terms of assignment and doubt clearance sessions. Okay. Hi students. So we have a new problem in front of you. So just read the question. 74.5 gram of a metallic chloride contains 35.5 gram of chlorine. Okay, so there it's a metallic chloride and they are telling it contains 35.5 gram of chlorine. So calculate the equivalent weight of the metal. Now you can itself tell me what method you need to apply chloride formation method, because they are talking about metallic chloride. So as per chloride formation method, tell me equivalent weight of the metal is equal to weight of the element divided by weight of the chlorine multiplied by 35.5. Now what is the weight of the element? Do you know that? No, because they are telling about, okay, we will do that. Mass of the metallic chloride. So they have given it as how much? 74.5 gram. Now mass of the chlorine. So mass of the chlorine is equal to 35.5 gram. Now you know metallic chloride what is the mass and chlorine what is the mass. How to get the mass of the metal? Subtract metallic chloride's mass from chlorine's mass. So mass of the metal is equal to how much? 74.5 minus 35.5. So this will come around 35.5. Okay. Now substitute in the equation. So you will get the equivalent weight of the metal. So I will do it in another color for your identification. So weight of the element. So tell me what is the weight of the element. Okay, this is separate. Okay. So what is weight of the element? Tell me weight of the element. We have calculated 35.5. Correct. Weight of the element. It is. I think this subtraction is wrong. I think because 35.5 plus 35 means 70 will only come. So it should be 39. Okay. Sorry for the calculation mistake. So it is 39. So what you need to do here? Weight of the element. It is coming as 39. Multiplied by divided by weight of the chlorine 35.5 multiplied by 35.5. So this will get cancels off. So what is the equivalent weight of the metal? It will come around 39. So equivalent weight of the metal is equal to 39. So this is how we apply the chloride formation method. I hope you understood. We have explained almost all the three methods and also the example question on law of equivalence, and there are still more questions that we will see next time. Thank you.